Okay, I'm gonna go over that briefly, real brief again, because I wasn't recording. Um, we have built these primitives already. We have the burnable payment. We've built what we were calling the subscription manager. I'm going to start calling it a billable wallet because that's quite a bit clearer. And then we've also built factories for everything. The billable wallet could be decomposed into this wallet here and billable wallet. So that'll be the first thing we do on our outline after going over this is this bit here, and that'll get into contract inheritance, which is good. And then later for the third item here, we're going to look into forwarding commands. And if we can get that down, we'll be able to maybe move on to a multi-sig wallet that forwards commands, but only when a certain number of people sort of agree that it should be forwarded. That's about it. It's worth thinking about how the burnable payment might also branch out into other versions, but we probably won't get there this stream. So, okay. And if my sound cuts out, I apologize. My sound card actually broke. I had to bust into it and literally reconnect a wire in there. So hopefully that doesn't happen. No. Hardware wallet. So the question is, will we make the wallet? Yeah, please. If we make the if we implement a wallet in a smart contract, the contract itself is going to be controlling the funds, and that's sort of fundamentally different than how a hardware wallet does it. A hardware wallet actually holds the private key. One thing that we could do that's sort of related is that without really getting into the contract code, we could actually make an interface. That could be something we do later this week, actually. If you could make a note, David, of this. Later this week, we can make an interface that interacts with any kind of smart contract, but actually uses your hardware wallet to interact rather than MetaMask. I believe that's pretty simple, although I've never done it. But we can look into that later in the week when we start building interfaces. So in that way, we can sort of make anything we build hardware wallet compatible. But for the wallet contract itself, its funds will be controlled by this contract, and I guess it just depends on which contract or which Ethereum identity that contract listens to, and that key pair itself could be pointing at a Ledger key pair or a MetaMask key pair, and then it's just just a matter of whether our interface is intelligent enough to connect to either one of those two. So our contract design won't really care whether it's a hardware wallet or not, but later we can make sure that works in that way. So good question, David, and I do think we should work on that. That would be a good thing to do this week. I haven't done it. Should be simple, so we'll see later. Maybe on Friday. Okay, so let me close my email here, so you guys don't have to see my porn. That'd be embarrassing. Let's see. Later we're going to use this proxy code from Haven. I'm going to just close it for now because first I'll take the link. Oh, it's already there. Okay, cool. Let's close that. And let's get to Remix. And I'm going to take these and put them in the links as well. Oh, that's just the general contracts page. We don't need that in there. Okay. Let's erase all this. Well, no, wait. That's what we want, isn't it? It sure is. Okay, so in a way we already have this visually split up. So if we can ignore this factory contract first of all, and this first half of the subscription contract is all about the owner and depositing and withdrawing. So in fact, this might be just as simple as this. So we'll just end that there and change the name here to wallet. We can maybe even call it basic wallet, but that's okay. We don't need to do that now. And then we'll just start a new contract down here, contract. And again, we're going to start calling it a billable wallet now. I'd like to. I mean, if you have any any objections to that, please speak up in the chat. And we're going to make this inherit the wallet here in a second. But first, let's just go over here. So the wallet has an owner with a modifier that can use that ownership to prevent certain things. Upon construction, the owner is set as an argument, so that means it won't automatically be set to you. It'll be set to whoever you say to set it to. So you could set it to yourself, and maybe the interface would naturally assume that you'd want to do that. But another contract, for example, our factory contract, can use this constructor to build a wallet for somebody else. So that's why we put that in there. Anyway, so we have events here, deposit, withdraw, and then the functions for those. And the fallback function, of course, is just going to accept any money from anywhere. And it'll count that as a deposit, emit the deposit event. And then the withdraw, just require that only the owner can do it. I recently saw that you can actually take off the parentheses here if there's no arguments in the modifier. I kind of like how that looks a little better. Makes it look more like a keyword. I don't know if that's good or bad. In any case, I think I like that. So, and the only logic here we have in all of this wallet stuff is really the require. So we have the require in this modifier, which is called here. And we also have this require, which just requires that the amount is less than the balance. And again, this line here, it's important to note that we don't have this here to actually prevent people from, the owner from taking out more than they can, because even if we had this line commented out, they still couldn't do it. They can't break the rules of Ethereum and pull money out of, more money than is allowed out of a contract, or that more money than the contract has. That will still fail. But the reason we put this in here is because now we can check it ourselves, and then if it fails, we can give them a better error message. So with requested withdrawal amount exceeds, I'm just going to say balance here, exceeds balance. And then that way that we'll have a much better hint, if somebody else is building an interface on top of this, they'll run into this error much sooner rather than some out of gas or failed to execute error. So, yeah. Okay, so that's our wallet functionality. That's pretty simple. And now, so I guess the first thing we should sort of head towards is we're decomposing this. Now let's see if we can make the whole thing functional while still leaving it decomposed. So the next step on there is to inherit this wallet as part of this BillableWallet contract. So contract inheritance. I don't want to mess up my syntax here. Inheritance. I just need the contact. Is okay. It's just is. That's pretty easy. Is wallet, like that, and that might really be all we need to decompose this. It's fortunate that we already had our code grouped in that way. It almost seems too easy, like I planned it or something, but I guess in a way I did deliberately group things like that, and it just worked out nicely in this step. So, and now we have this billable wallet that everything it's talking about has to do with these billers and process bill, call bill, and set bill rate. So that's pretty cool how that worked out. I guess the only thing now to do is to test it. So let's do that. Let's compile. Nope. Oh, we don't have a subscription manager anymore. We have a billable wallet. And so actually, while I'm doing this, I should change the name of our factory here. Billable wallet factory. And something we might do later is actually just change this to a factory like this, and then have it be able to create multiple different things. But for now, we're just going to stick to the old, our established strategy of making a specific factories for a specific kind of contract, and we'll leave it there for now, although we could revisit it later. Still, one argument's expected, but one argument given, but expected 0. Oh, it's because we have a constructor here defined. We don't have a constructor for this defined. So let's just do that. Constructor. Where should we put this actually? Put it right in the beginning here. Constructor, and then once again we're going to address owner. And now the question is, we would like to be able to, when this constructor is called, forward sort of, then call the wallet's constructor so it can set the owner. So let's see about that. Solidity, inheritance, constructor. See, that looks like other people are having inherited constructors. That's the trick is in the definition. Oh, you just do that. It's sort of like a modifier, I suppose. Similar syntax to a modifier. That's pretty cool. That's elegant, actually. So here, whoops, alt tabbing when I mean to alt. I need control tab. So yeah, just like a constructor. I mean, just like a modifier. Just the name of. Okay. Does that compile? It compiles. That's pretty cool. And we have a message. Yes, yeah. So just to catch you up there, Saron, what we're doing is, let me just go back to this image really quick. Where did it go? So this is just some brainstorming I did. This billable wallet item in here, this is really just the subscription manager we've worked on already. The billable wallet term, I think, is a much clearer. And so we're taking what we built last week, the subscription manager, and we're decomposing it into the wallet functionality and the billable wallet itself. And so the code that we're working on here is literally the same contract code. I don't know if you saw it, but I just changed the names from subscription manager to billable wallet. And you can see here's a leftover one right here, so I need to change this as well. So we're working on the same exact code, but we're decomposing it now into a wallet and a billable wallet, and then yes, as you guessed, that's inheriting the wallet functionality from the billable wallet. So that's our mission for now, and then here is our outline here. We've done this already. I guess I'll just cross that off like that, and we're on number 2. And after we decompose these, we're going to look into forwarding commands from one contract to another. So that'll be where we move into next. But first, we're decomposing this and just trying to make sure it remains functional even after we decompose it and use inheritance. So let's see. I'm just going to do a quick scan for anything that's called Subscription Manager. Okay, I don't see anything, any outdated terms. Let's make sure it still compiles. Nope. Oh, new. Just like that. Okay. And here again. Okay, this is just saying that there's no visibility. Same here. That's all the only warnings. I guess, once again, I'll look at the static analysis. It always seems like a waste of time to look at these, at least for the contracts that I work on. Yeah, so sometimes it'll warn you not to use now because it's not exact. And that is on, let's see, line 68. So here, when you use the keyword now, there's an issue. There's sort of it's not necessarily straightforward how the blockchain enforces that when a miner mines a block. The miner can just put in whatever time they want, and then there's a certain tolerance where if the time is sort of too far off it'll get rejected, but there's like this wiggle room. So because of that wiggle room now is not exactly dependable. I've always found it dependable enough, especially when we're talking about long lengths of time, and especially when you consider that really the miners can only just kind of wiggle it. And these are miners. It's not like we're worried about every single user. This now will really only break down if the miner behavior really starts getting wacky. So that's why it's warning us about the now bits. Fallback function requires too much gas. And yeah, and then it always gives me these warnings about way too much gas, even when there's no loops. So I don't know what's up with that. I guess again I'm just going to ignore them. Okay. So let's see. Let's run this in the VM first, just to make some testing easier. And again, we're just going to test out the functionality, just one or two. We don't need to do a whole bunch of testing, but just to make sure this works, even though we've decomposed it now into two contracts, one of which inherits the other. So now we have three options here. We are going to deploy a billable wallet first, although we might as well, afterwards we'll just deploy the wallet too, just to see it. Okay, so we need to deploy it with an owner. We will take our first address here. Remember, when you're in the VM, it's going to use these addresses, not anything in your MetaMask. So anyway, we're going to copy that and deploy here. Okay. Oh, look, their interface changed a little bit. That's interesting. Yeah, things a little bit clear here. That green check mark is new. Anyway, okay, so here's our deployed contract. We have a fallback, all our stuff. Let's see, what could we test here? Let's just set a biller and then bill from that as that biller. So here's our second address. We'll put that into the set bill rate. And we'll give them a rate of, it doesn't really matter. I'm not too worried about testing the logic as long as things work. So I'm just going to put in whatever that big number is. Reverted. Oh, because I'm still on the, I need to go back to the owner and then try that again. Okay, so one with a bunch of zeros. And I'm never sure whether to put quote marks around these addresses as arguments. Let's just see if that works. Oh, it does. Okay, so you don't need to put quote marks around your addresses when you put them in. Okay, so we've set the bill rate. Now let's just make sure that when we put billers in, we actually get that bill rate back. There we go. That looks good. And finally, let's just because it'll be quick, let's go to the biller and actually try to bill. So call bill. Did not work. Okay, debug the transaction. Let us do that. Let's debug that transaction. Although is that the one that? Yeah, that's the one. Okay. Back to the beginning. Require the biller. Yep. So it got past that require, and then it goes into the process bill, which is here. Biller address dot transfer. Oh, it's trying to transfer. We don't have any money in there. Ha! That's why. Okay. So, oh, and you know what? I bet if I look, now this should have given me an error. Okay, so the reason that didn't work, in case you missed it, is because the contract has no money in it. So of course it can't send anything out to the biller when they ask for a bill. So we should put money in, but first I want to look into something that call bill goes into process bill. Oh, we don't have a require here like we did up here. That's what I was saying, thinking was missing. So I'm just going to copy this over and we'll change the message a little bit, but we're going to do that and then require that billable amount is less than the balance, or less than or equal to, and then we'll just say bill amount exceeds balance. Now what should the biller do when they call this and the they can't bill because there's not enough money in the thing. Well, that's something we'll have to figure out later, but at least now, next time we run into this kind of error, we'll get a better error message. So let's recompile that. Run it in the VM, and let's trash that one. Okay. I'll run through this quick because we've already tested most of it. We almost don't need to test anymore. Okay, there's our contract. We want to set the bill rate for, oh, looks like I made the owner the second guy on accident. Okay, that's confusing. We'll make the biller the third guy. Get his address, go back to the second guy, that's now the owner. So there's the biller. We want to set his bill rate to 1 with a bunch of zeros again. Do that. That worked. Okay. And we can see the biller now. That's good. So now let's change to the biller. Well, first let's put some money in. How about that? Let's put in like 50 ether, just to make damn sure that it'll have money there. Okay. Now let's go to the biller and let's click call bill. There we go. So that seemed to work. Yeah, that looks good. We can even look at this more if we wanted to. We can see the log, for example. Biller address, amount billed, bill process. There's our event. Okay, so that all seems to work good. Good. That went pretty quick. I'm actually pretty happy with that, how quickly we were able to decompose it. And again, you can see that Solidity is pretty readable once you get into it here. BillableWallet is wallet, and the constructor right there, which calls the wallet constructor. So that's all pretty good. Whoops. I want to be looking at that. Let's see. So, well, so let me try to answer your question, say, Ron, and let me know if I've missed it, and then we can re-attack it. But our contract file here, this oh, it's called ballot.sol. Let's change that. That's wrong. How do we change that? Just because that's a bit silly. Come on. I want to rename it. Come on, this can't be that hard. Okay, I can't change it. Well, so ignore this file name up here. We've been saving it. I guess we'll begin saving it as BillableWallet.sol. We might even put this into 2 different files. But our compiler, when it sees BillableWallet is wallet, then it then goes and it compiles all 3 of these, right? It compiles them in this order, and when it sees that the BillableWallet is wallet, it just takes this compiled bytecode here and includes it as part of this contract here. So in terms of the bytecode, we aren't really ending up with anything decomposed. You know, when this contract is deployed as a BillableWallet, it looks almost exactly the same as if we put all of this code all in the same contract. The only difference is that we've split the code up here in our file, and I guess, you know, one of the benefits of that is that now we can deploy a wallet separately if we'd like. Does that answer your question? How does the inheritance know about the wallet? Oh, and then maybe another part of your question here is that when we deploy, we do have to choose a specific wallet. So when we go look at any given address, so let's say I showed you this file and I say, hey, I deployed the contract and left it kind of vague. Well, without knowing what I really meant, you could know that if I point you to an address and I say there's a contract on here from this file, you could know that that address is either this factory, this wallet, or this billable wallet, or, you know, an instance of any of those. It's not all 3, it's a specific one of those. And so when we deploy, that's why we have to choose one of these. And this file just is, when we're looking at an address on the blockchain, that address will never represent this whole file exactly. It'll just represent a specific contract that we've built from this file. So we could have a list. We could have this file full of like 20 or 30 or 50 different contracts. I mean, you could even do something like, if you really wanted to get sort of inelegant, you could say contract, like, for example, multi-sig 3 of 4, and then you could define that. Whoops. These. And then you could like copy this and paste it a bunch and change these numbers. Like, that would work just fine. And then you'd have a file full of these different contracts, and they'd then you could deploy whichever one you wanted, as long as you feed your compiler this file and you tell it which contract specifically to deploy. So let me know if that answers your question. I'll just pause here for a couple seconds because I know that the stream lags a little bit. So I'll just give it a couple seconds. Let me know, say Ron, yes or no, if that answers your question. Oh, and I have some chats on the stream. Okay, cool. All right. So yeah, so I think that's pretty much number 2 already crossed off there. Pretty simple, not too complicated. We're half an hour in. That's good. That's great. So again, this is just going to be an hour long. So with the last half hour, we're going to talk about forwarding commands from one contract to another. And it's kind of a confusing thing, and it's going to involve some Solidity assembly, which I don't have a lot of experience in. And we're going to be looking at this page here. I should just make that a clickable link while I'm here. Oh, wait a minute. There we go. So this link here, oh, and I don't think this is posted for you guys. I'll publish it so you guys can go to these same links while you're watching the stream. That'll be the latest post on the blog there. But so this Haven is a company that's doing, I worked with them in Australia. They're doing a stable coin, but part of their project is they had to use this proxy contract, and this contract takes any call. Well, first you give it a target, which is some other contract, and then you can pass any kind of command to this, and if this contract doesn't recognize it, as it's saying up here, if you send it a message, or if you send a command to this contract that it doesn't recognize, it'll just pass it forward onto the next contract. And the way it does that is by way of the payable, or sorry, not the payable, but the fallback function. I'm just going to go load that up and talk about that a little bit, because Solidity fallback. We've been talking about the fallback in a sort of a narrow use of what it actually does. So this fallback function, we've been talking about it as if sort of when you send Ether to a contract, you need the fallback function defined and you need it payable. And so in our contract, that is right here. This is the fallback function. And we've been talking about it so far as like that's what you need to do to be able to let people to just send Ether without specifying any kind of command straight to the address and have it work and not fail. So that's how we've been talking about the fallback function, but it actually does a little bit more than that. The fallback function is what gets called when you send any kind of command to a smart contract that it doesn't recognize. And they're talking about it like an unnamed function, and that's maybe a better way to think about it. The function cannot have arguments and cannot return anything. It is executed, here's the key right here. It is executed on a call to the contract if none of the other functions match the given function identifier for it, or if no data was supplied at all. And the second part, that's what we've been exploiting, because when we send Ether, there's no data supplied at all. But it can also be triggered just when you're sending any command at it that doesn't that it doesn't recognize. And so we'll be using that to forward commands, and we'll be using this as a reference to how that's actually done. And here you can see it uses assembly. We're not going to be using all this code. They really put a lot of work into this. I was there when they were scratching their heads over it, and they had a lot of use cases for it. They really expected this thing to do a lot of work. So we're not going to be doing, for example, this emit that has to do with forwarding not only commands to the contract but events back towards the proxy. So we're not going to be messing with that. We don't need to do that. We are just going to be doing this block pretty much right here. That's about it. So let's see. I guess first I should take this code. Now I'm going to take this out and plop it in my text editor. After the stream, I'm actually probably going to split it up into different files. The wallet file and the billable wallet that includes the wallet file. But for now, look at all this junk I had lying around from last time. Okay, we can close that. And we can go into, sorry guys, just give me just a second. I guess I need to make another week folder, week 3. New file. Okay, plop all that in there. As I said, I'll probably split this up into a couple different files, but that's good enough for now. Okay, I'm going to take all this out of our compiler here, and we're going to say forwarder. So this is going to be super simple, and I think we're just going to have the fallback function and nothing else. So this contract, we're not going to try to, at first, just for now, we're not going to have it hold any funds. We're not going to do any kind of higher level functionality like multi-sigs. We're just going to try to make a contract that will take a command and send it to a specific contract. So we'll need to do a fallback function, and we'll also need to have some way of telling it where to actually send the command. So let's just get the fallback function in here first. And we'll make it payable. And then we need to go and look at our, where did that, there it is. I need to close these pages, they're confusing me. Whoops. So I guess before getting into the code, we have some choices on how to call other contracts, and I think I put this in the links. Yes, so this link here, the second link, is I would say it's essential reading if you really want to understand how one contract can call another. It'll be confusing at first, so jump in if you want, feel free to jump back out. But there are 3 choices that we have here. Whoops, I didn't, okay, that's fine. Call code, and delegate call. This last one is a newer one in response to sort of the limited functionality of call and call code. I don't want to get too into the weeds on this, but let's see here. Well, here we have 3 functions defined. So we have a contract D and a contract E, and each one of these functions is going to call some code in contract E here. And the question is, when you call the function in contract E, do you want the context to be contract D, or do you want it to be contract E? And the reason you might want to do that is contract E might be more like a library contract. Like it might have some mathematical functions. You might want to call contract E and actually have it operate on the contract D that's actually calling it. And if you want to do that, that's when you'd use delegate call or call code that sort of transplants the logic or the code from this called contract and executes it within the calling contract. And then if you just do call, you're actually directly, you're using this contract, not only the functionality, but also the context. And so when we talk about a command forwarder, so let me just talk a little bit about the motivation for why we would want to forward anything in the first place, at least as far as I see it. If we go back to this and we talk about this multi-sig wallet, if we want this multi-sig wallet to be able to send commands, not only just hold money, but also send commands to different contracts, then that wallet needs to be able to forward a command to something else. And so to forward commands, we need to have this contract E, whatever this other contract is, and we need to be able to send it from contract D. So we can imagine D is a multi-sig contract now, and maybe it's waiting for 3 people to sign. And when they do, now it needs to be able to send a command to contract E, which is maybe a burnable payment. So that might be a good example, that D is a multi-sig and E is a burnable payment, or a subscription manager. In any case, E is going to take some command and do something, and we want E to do that within its own context. We want, for example, the burnable payment to release the money within its own context or burn, or we want the subscription manager to update the billing parameters as we set. So because we want to operate in the context of E, we're going to go with the call. And again, you can look more at that, more at those differences in this link. You can read through here, and you could probably also look at, I bet this goes to docs, or maybe this is an EIP, but you can do some independent research on that if you'd like. So here, this Haven contract is able to use both of them. You can see here it's going to use delegate call, and here it's not. This is going to use the call, and we can see, and this is all assembly. These three call code, and delegate call, these are all assembly. They are not straight solidity functions, which means you need to start an assembly block here, which we haven't gotten into, and I don't want to get into now. And as I said, it's not something I have a lot of experience in. But you can sort of read some of it. We can see somewhere in here is a call. There's the call function itself. We get a result back from it, and we tell it how much gas and some other values to do. So we're just gonna, I guess what I'm gonna do is I'm just gonna copy this all and paste it into our code, and then we're gonna go through it and just massage it, make sure we understand what's actually happening here. And I believe that this is actually part of their, this is part of their fallback function as well. So you can see they're doing the same thing. They put external there, which we should also do. So I'm going to make that change to external. And then paste the code in, and then fix the indents. Okay, so one thing we haven't done yet is specify a target. I guess before getting into this code, we can do that really quick. Remember that the fallback function sort of by definition doesn't take any arguments, although maybe it can. Let me just go look that up real quick. Fallback arguments solidity. Cannot have arguments. Okay, that's what I thought. Right there. The function cannot have arguments. So what that means is that we can't just tell it where to forward the command as part of the forwarding call. So we need to have a little bit more structure here. It's going to be pretty simple though. It's going to be just address target, just like that, and we want to make it public. Oh, public like that. Let's see. I think they did the same. They did a similar thing here. Okay, so they're saying proxyable. That's their own type of contract that helps with events and stuff. We don't need to have our own proxyable contract. So it's just going to be an address, target, like so. And then we need a way to set the address, and I'm going to make that part of the constructor. We have two choices here when we want to set, well, we have a few choices. First of all, we could just hard code the target in right here, and we could say 0x, whatever the address whatever the contract address is, but that would be a bit silly because we'd have a forwarder that could only ever forward to one contract, and that would be pretty useless. Another thing we could do is we could have the constructor that sets to a specific target like this. And we'll do this for now. We might change it later. But you'll notice this is not much better than what I just wrote because we're still setting the target initially and we never get to change it. The reason I'm doing it this way and not allowing us to update is because if we update, then we have to figure out who can update. Can anybody update it? We'll have to have some sort of owner, which is probably a good way to do it, but I don't want to worry about that quite yet. We can work on that later. First, I want to just get this forwarding functionality working. So we have a target, we have it, and we set it in the constructor. And then here, so let's get back to here now. I am going to take this line out. That's part of what Haven is doing. And it has to do with they were using this proxyable thing. This is a contract that they've defined. You could go look at the source code if you want. It's in the same repo. But that proxyable has a method called setMessageSender, and that helps them get around the fact that they don't want their target to consider the calling contract the sender. They want the user to be the sender, so they need to sort of set that. It's their way of getting to a similar functionality as delegate call, but we're going to leave that out because we do want our forwarder to be the sender, because this might evolve into a multi-sig or some other kind of group type mechanic, and in that case, if this group type contract does call a burnable payment, we'd like the burnable payment to consider that group-like contract itself the initiator of the action, not whoever did the final push that triggered the call. But anyway, so okay, so now let's get into the assembly here. It doesn't have a comment here. It had a comment earlier for similar lines, so I'm just going to copy that. This is the same as up here, which has this comment. So I'm just going to copy that over as well. So copy all data into free memory region, and that looks fine. I'm not going to say I understand a lot of this. I don't know why it's copying to that specific area or loading from, but it's clear it has something to do with forwarding the arguments. And here we must explicitly forward Ether to the underlying contract as well. That makes sense, and in fact it's sort of like if we go look at our factory contract, we sort of do something similar here. Not on a BillableWallet because we don't send any value. If we wanted to send value along with this when we create a BillableWallet on this factory, well, okay, I'll just go look at the burnable payments code because that actually shows it. So let's just look there real quick. So here's our function, new burnable payment, burnable open payment, and this bit right here, new burnable payment dot value. Here we're forwarding value as well. So that means when we call this new burnable open payment and we send Ether to it, this line not only creates the new burnable open payment, but it also forwards the Ether. So that is a similar thing to what we're just about to do here, but of course this is using assembly, so it's going to look different. But here is the part right here, this call value. That is where we forward that value. So let's go back here. We should be looking at this. Okay, let result equals call. We pass the gas. Now this, I'm not sure what this is. S-load target slot. We'll have to get back to that in a second. Call value. Free pointer is that thing. Call data size is that. Okay, it looks like we're gonna have to pull some more stuff from here. Let's see if any of that stuff is defined. We have a target, use delegate call. There's no other globals defined. Oh, here we go. Size, call data. Oh wait, this is emit. Oh, I'm looking at the wrong one. Sorry, guys. Got a question, I think, or a comment? Top of the if block. Whoops. Are you sure? Okay, I'm just going to do Control F. There's only 2 in the whole. Does this inherit anything? Owned. It seems to not be defined. You know, it might be a assembly keyword. It's not. Yeah, it's not an inherited contract either. I just checked just before I saw that message from you. Well, it is owned, but I'm pretty sure that owned doesn't have anything in there. I guess we can check. I bet it's a solidity. I mean, an assembly keyword. There's no highlighting, so it's hard to tell. I know that free pointer is not called data size. I believe that is also a keyword. And gas might be too. These might all pretty much be. I know that call value is too. So let's just assume that everything that we haven't defined up here, because it doesn't define anything else here either. The only other things it has access to is this, which it doesn't use. So, okay, we're gonna just assume that everything there is, these are all keywords in the assembly. Okay, and then again, let's go grab a comment from this first part, because I believe it's the same, these last 2 lines. Okay, I guess let's just see if it compiles first of all. It compiles, that's great. Again, it's complaining about the constructor not having a visibility, but that's I'm not going to worry about. So now we can't run into the VM because this, well actually, I wonder if this VM will keep, I don't think this will keep things between, okay. Rather than mess with the VM, I am going to deploy this on Ropsten, and I'm going to point it toward, let's see, what's something simple that we could use. We have burnable payments. We also have our old subscription managers. I guess what we can do is deploy. Let's deploy a subscription manager and see if we can call bill. Well, that just gets complicated because then is the forwarder going to be the biller? I mean, I guess it should. You know, I'm just going to make another test contract here. That I think would be the simpler. Let's see. So test. Okay, so we have this really simple contract here, okay, so now, yes, in the VM we can deploy both of these, and we can deploy the test contract first. Let's do that. First we have to compile. Okay, deploy the test. There it is. We can copy this address, and now we can go and deploy a forwarder with the target of this. That's the address of the test contract. I copied it there, and now I'm deploying the forwarder with the address of this. We just deployed the test contract, and I'm going to give the address of this contract to the constructor here to set the target of the forwarder to that address. So click deploy. That all worked. And so here are our two bits here. We can look at the flag, should be false. If I click this, it'll turn to true, but instead of clicking that, I'm going to see if we can use this here is a problem. We're not going to be able to test this right now because our virtual machine, of course, doesn't have a way for us to build the custom transaction we'll need to call the set flag function to call the forwarder with the set flag function. We only got 6 minutes left, so I think I'm going to maybe stop the stream there. We might have to do some weird things with the ABI. So I'll have to experiment with this, guys. I'm sorry I couldn't really show it off. We got most way through our outline here, though. It's too bad we can't really test it. I can't think of a quick way to test it. Because we need a way of sending a command to the forwarder for a function that it doesn't have. We need to be able to send the forwarder the set flag function. If we can do that, then this fallback function should catch it and then pass it along to the test contract, which should execute it successfully. But our VM here certainly is not going to let us do that because it says, well, forwarder contract only has 2 functions. And so what I'm probably going to have to do, and I think I'll experiment with this on my own, but just so you guys know my thought process, what I'll probably do is deploy both of these on Robston. Then I will probably take the ABI of the test contract. Well, I don't know. I'll try taking the ABI of the test contract and calling the set flag, but setting the address of the call to the forwarder and see if that works. And if I run into a wall there, I'll probably just contact the Haven guys because I was right there with them when they were working on this stuff. And if I can't immediately figure it out, I'll probably be able to get some help from them. So yeah, I think I'll stop the recording there and upload this video in a little bit. So but let's look at what we've done so far. So we didn't really do a lot of, I would say, practical development. You know, if we look at what we've done, we decomposed something, but we didn't add any functionality. I mean, in a way, you could sort of say that we have this wallet function. So in the few minutes left, I want to save this code first, okay. So if we take the BillableWallet code that we decomposed, put it in here. One thing that we do have that we didn't have before is, let me just close, do all that, compile, is that we have this wallet contract now for free, and it's not that interesting. All it does is just let an owner deposit and withdraw, but we do have it now, and all we had to do is decompose it. And you can imagine that now we've made a BillableWallet out of it, but we can make, I don't know, I have 3 minutes left. I guess let me just brainstorm here just to illustrate this. So we can make, what do we want to make that is a wallet? Any ideas, guys? Yeah, it must be a built-in. Interesting, guys. And you know, when I was there, they were working on this. I'd hate to find out that this thing is actually unfinished and target slot is somehow undefined. If that's the case, I will do some research and figure out, what to actually do here. But hopefully that's not necessary. Oh yeah. Um, okay, so I'm just gonna spitball some ideas here in the 2 minutes we have left. Now that we have this wallet thing built, we've made a billable wallet. What else could we make? What else do you need wallets for? You could make a multi-sig wallet, although that gets into command forwarding, so I don't want to get into that yet. Something that's sort of like a multi-sig wallet is you could say, let's say multi-owner wallet, to where everybody who owns it can send, withdraw, and let's just see, that'll probably be really easy. I could probably just write that in like a minute here. Watch how easy this is going to be. Okay, we want to make it external. We want to make an array of, let's see, address. Well, okay. Anyway, that's the idea. Time is up. I'm going to stop the recording. I'll keep streaming in case you guys want to see this. I'm just going to keep going on this and see if I can make a multi-owner wallet. The idea is going to be to just make a wallet that 3 people can all spend from. They don't have to. There's no multi-sig. It's just any one person can withdraw. But we're just going to see if we can make that real quick.